Hello, good evening, everyone. Can you hear me?
Yes, ma'am.
Okay. Is there anyone to join or should we start? Let's wait for another 5 minutes or else we will start. Hello. Okay. So we will start now. Today we are discussing about week 12 doubt. Have you guys watched the videos for week 12 lectures?
Partially.
Partially. Okay. Last time we have covered this week 12 lectures, right?
Yes, ma'am.
Okay. Any doubt from that lectures? Hello. Am I audible?
Yes, ma'am.
I guess screen might be visible, right?
Yes, ma'am.
Okay. So any doubt from last lecture?
Ma'am, apart from last lecture, I need some clarification regarding extra activity. Can I ask
Sorry, which one?
the extra activities we have got for week 1 and week 2 that we have completed?
Okay. Like if there is any conceptual doubt, you can ask. If there is any like how to
No,
submit and all
I
this thing.
I have very simple doubt. Actually, I got some marks in activity 2, but recently, maybe tomorrow, we got the marks updated on dashboard. It is showing very less marks instead of what I got. That then I have written a mail to support team also. I got a
Okay.
reply to post the same query on Discourse. So what should I do?
So like anyone replied on the discourse?
No, I have not posted Discourse on Discourse because I don't think someone can help me in on dashboard because it is if my marks are showing less or incorrect, then I should report to support.
Yeah, yeah,
How
yeah.
someone can help me on dashboard?
Yeah. So was there any like response from the support team?
They just responded that post it on Discourse.
Then please post that on the discourse and like any mentor or instructor will put there. If there is any solution, they will correct it and report them.
Okay, if I post it on Discourse, then also someone can take action.
Yes, yes. Also, I will also inform about you. What's your name?
Rajiv,
Your roll number?
I have to check that.
Okay, no doubt.
If
No problem.
uh, I have to post in subject wise or some operational kind of category.
Okay, okay. Then you just put in the discourse with your name and roll number and whatever the query is, we will sort it out.
Okay, on the course specific category only.
Yeah, yeah. Whatever
Okay.
it is, you just put there. There will be
Okay.
someone who will solve it.
Okay. Thank you.
Okay. Any questions from the last week? Yeah. We will be taking the doubts of week 12. So in last lecture, was there anyone who attended the last lecture? Hello.
Yes, ma'am.
Okay. We had discussed some continuous random variable, right? Continuous distributions. So at the end, I have explained exponential distribution and asked for one integration. Anyone tried it out? The exponential distribution, if x is a random variable, is a random variable such that it follows exponential distribution, so that its PDF will be f of x is equal to lambda into e power minus lambda x whenever x is greater than 0, greater or equal to 0, and 0 otherwise. Do you remember? We have discussed these things last lecture. Hello. And the CDF of the same, like cumulative distribution function for the exponential distribution function was, we have calculated this also. It was nothing but the,
Ma'am, yesterday's lecture was about week 11.
yes, the week 12 open session was like on 10th December. Were you there?
No, ma'am.
Oh, anyone who attended lecture on the 10th December? Okay, fine. Okay, x is random variable which is which is following some continuous distribution. I'm going to start this one. If you have any doubt on this, please ask me. Or if there is any doubt from week 11, you can also ask that, okay? So, you know, right? PDF and CDF, you know. Yes.
Ma'am, I have a doubt in week 11 topic poison.
Which one?
Ma'am, poison topic.
Sorry.
Ma'am, poison distribution.
Okay. Okay, fine. So if we go with the week 11, just a minute, let me check if there is a schedule for week 11 also, then it will be double, right? So you haven't watched the videos for lectures for week 12? Anyone?
I have watched, ma'am.
Sorry,
Ma'am, just started.
just started. Okay. And you also haven't attended the last lecture, right? 10th December lecture.
Yes, ma'am.
Fine. Okay. Okay, then we'll continue with week 11. Just tell me where is the problem, in which part you have problem? Hello.
Yes, ma'am.
Yeah, week 11 question you were asking, right?
No, ma'am, topic.
Sorry, week 11?
Week 11 poison topic, ma'am.
Poison topic. In poison topic, like, what's the problem?
Distribution, ma'am.
Distribution. Poison distribution.
Yes, ma'am.
Okay, you didn't get that topic. Is that the problem?
Yes, ma'am.
Okay, okay. If we go like that, then the whole session will be on week 11 also. Like, is it possible? Can we discuss the week 12 assignment today and have the 11 doubts or topics tomorrow? Like, what do you
Okay,
want?
ma'am.
What?
Yes, ma'am. We will do like that.
Fine then. So let's start assignment of week 12. Is it fine or yes.
Before assignment, we have to watch the content
Yes, you haven't watched the content of week 12, right?
No, ma'am. Because
Okay.
today is the last date of week 11 deadline. So,
Week 11 deadline.
yeah.
Oh, okay then.
So you can explain week 12 if there's no problem.
But week 12 open session has done in the last lecture, right? Like it's already available on the YouTube. It like doesn't make sense to repeat the same content. So like today we were about to take the doubt session on the week 12.
Okay. I was not attended last session, that's why.
Okay then, give me just a minute. I will check it out. Hello. Hello. Can you hear me?
Yes, ma'am.
Yes, ma'am.
Yeah. Okay. So we will continue with the week 12 session only. If there is any doubt regarding the week 11 topic, we have another, like you can ask in the TA session regarding the same. Till now, we will discuss this week 12 topic. Even though if you haven't watched that videos, you just ask me if there is any doubt, then we will continue. Okay,
Okay, ma'am.
fine. So, yeah, like you have studied in week 11, there are some discrete distributions, right? You might have studied the discrete distribution, discrete random variable. Right, I will start with very
Yes, ma'am.
basic so you can understand what's going on here, right? So whenever there is a random variable, there are two type of distributions are there. One is discrete and one is continuous. So discrete you may have learn in the last session. Discrete distributions like Poisson distribution, binomial distribution are examples of some discrete distributions, right? And another one is continuous distribution. Okay. In continuous distribution, like you have, for example, have you heard about the uniform distribution ever?
Yes, ma'am.
Yeah. Those who have started the lectures of week 12, they like it's the second or third lecture only about the uniform distribution. What is uniform distribution? So if X is any random variable which is following some uniform distribution between A and B, then it takes some constant value throughout this range A and B, throughout this value, right? Let's say that value is K. Like for example, if it is a like X and Y kind of, okay, and here it is A, here it is B, and we are saying that the function is following uniform distribution. That means between A and B, it's taking some constant value K, right? Let's say this value is K, but we don't know what this value is. So we'll find what is this value. So like in discrete distribution, how do you used to find the P? You used to calculate PMF, right? What is PMF?
Probability mass function.
Right. So here we have probability distribution function. As it is a continuous function, you cannot find the probability at particular point. So you have to find the probability for a particular range. Like probability of X lying between A and B. Kind of that you have to calculate. Okay. Right. So this is given by integral A to B f of x dx. Do you remember how you used to calculate this probability in PMF? You just used to calculate the probability, right? Here it is integration, so we do like that. So f of x is what? This k is our f of x, right? So you just put this k here and you will be able to find what's your probability there. Fine. What's the probability that function taking that value? Okay.
Yeah,
I'm explaining this
Yeah.
topic as we are going to solve the questions based on this topic. So if you guys solve it, what will be the value? Anyone?
K into B minus A.
Sorry.
K into B minus it will become KB minus KE.
I'm here fx equal to K, ma'am.
Yeah.
K B minus A. K into B minus A.
K into B minus A. Yes, ma'am.
Okay. Sorry, actually there is one mistake. Like we usually have this integration. Yeah, you just tell me, when you used to do PMF, if you sum over whole the part, what was the value? Like sum of all the probabilities will be
1.
1, right? So
Oh.
here also it will be 1. I have written the A to B, but it's nothing but the 1 only, right? If we are finding the probability on this whole region, then it will be obviously 1. So it was not wrong, it was just an indication. Fine, because the point X will lie between the A and B is the probability 1 only. So if you calculate it, this will be, this will be f of x is k and a to b dx. So you will get from here that this k into b minus a is equal to 1, right?
Yes.
Yes, ma'am.
What does it mean? We were finding this value of k only. So the value of k is b minus
B.
1 upon b minus a. Now what
Yes.
this b minus a indicates here, like what is the significance of it? So it's just that if x is any random variable which is following uniform distribution over the interval a comma b, then yes, then anything?
Yes.
Then its PMF will be 1 upon 1 upon b minus a. Fine.
Means
Because this,
summation.
yes,
Do you mean summation of that, or
sorry, d
just
means
means do you mean summation of all those? No, but
where is d?
here
Ma'am, here how the PMF is equal
Integration
to
is
1
nothing but
minus a.
summation.
Yes, integration is nothing but the summation.
And
What was
ma'am,
your doubt? Yeah,
here B should not be equal to A, no?
sorry. Yes, yes,
In
b
the
should not be equal to a. Otherwise, there will be no range or domain. No? See, in PMF, in discrete random variables, the points were countable, right? So if there are countable points, you can pick any point and they calculate the probability of it, right? But in continuous, when it comes to continuous random variable, there are uncountable number of points. So you cannot pick one point and find the probability of it. You have to select one interval here, right? That's why we have taken the whole interval and we find out what is the PMF. This one, this line, this which we have called it K. This is nothing but our f of x. Okay. Are you getting my point? Okay. So whenever there will be a uniform distribution, your PMF will be given as 1 upon b minus a. But this will be for only x lying between a to b. So from your last lecture, week 11 lecture knowledge only, can you tell me what will be the PMF for rest of the part? Which we say at otherwise like x is less or equal to, yes, right? It will be 0 otherwise. One more thing I want to introduce you is CDF, the cumulative distribution function, which already you know, right? CDF you might have heard in the last lecture also, like in week 11 also, even though if you haven't attended week 12 class. So what does it mean by CDF of any random variable or any distribution? Anyone? This is
Summation of
yes,
distribution.
summation of
All the distribution.
sorry, can you repeat? Your voice is not clear. In CDF, generally we denote by capital F of x. This is nothing but the probability of all the x which are less or equal to this given small x, right? If let's say this is a uniform distribution, okay, this is some uniform distribution followed by some x, and this is some random point C lying between A and B. So if you want to find the cumulative distribution function at this point C, then you have to calculate, you have to sum up all the probabilities before this point C, right? The similar thing you have done in the discrete random variable or discrete distribution also. There it was a countable point, so you used to sum all the probabilities before the C, right?
Yes, ma'am.
It is cumulative distribution, that's why we add all this thing. But here the case is continuous, so we have to go with the integration, right? So how do you use to calculate, how do you use to do the CDF in discrete random variable? The logic is same here also. We will do, you used to sum all these probabilities before C. We will do, as here we have taken small x, will integrate, but from where to where? That's the question.
A to
A
C.
to
A to X. I think A to X.
Yes, A to X. So if you integrate, then what is your f of x now here first?
F of
See,
X 1 upon B minus A.
Yeah, see, our x is following the uniform distribution A to B, and f of x is, so f of x is PDF, and we just discussed that f of x is nothing but the 1 upon B minus A. So you just calculate it. What will you get? It will be nothing but the 1 upon B minus A is constant. So this is nothing but the x minus A upon B minus A, right?
Right.
But for which part? Like we have to define the f of x for the whole R, right?
yes.
So f of x will be 0 till when x is less than A, right? And
Yes.
it is x minus A upon B minus A whenever your x lies between
A to C.
you just calculate. Is it from A to C or A to B?
A to B.
Yeah, it will be A to B. And what about beyond B? Sorry.
Beyond B, ma'am, again 0.
It's a CDF. It's not probability mass function. It's not a probability distribution function. It's a cumulative distribution function. Whenever you calculate after B,
minus
you
divided by
have
B.
to, let's say some point here, D. So whenever you want to find the CDF at this point, you have to add all the probabilities before that. So whenever you go after B, whatever
It's
the,
one.
yeah, it will be 1, because your event will be a sure event in that case, right?
Yeah,
Yes.
You got this point? Okay.
yes.
Okay. Then
Ma'am?
there, yes.
Ma'am, in case of discrete also, no, like CDF, the last one will be 1. Like
Yes.
after that.
Yes, the concept is same in both, like discrete random variable. You can say discrete distribution also. Discrete and continuous, both the distribution. The concept is same. The thing is, in discrete distribution, we have countable points. So we take the help of summation, right? And here it is uncountable points. So we go with the continuous. And in detail, you know that this continuous is nothing but the summation only, right? You will learn this thing in Riemann integration. So it's uncountable points. That's why we integrate it. So in discrete random variable also, once you go beyond all the, whatever your last point will be, after that CDF will always 1.
And ma'am,
Okay.
one more thing, ma'am. Ma'am,
Yes.
how can we surely say that it will be like 1? Because
we have to add all the events before it, no?
Yes.
And that event also. So
See, we are adding the things, right? We are
yes,
adding the
ma'am.
things. Let's say if you are adding something and you got 1 and then afterwards you are adding 0, does it change your addition value?
No, ma'am.
So,
Okay.
do you got my point? What I want to explain?
Yes, ma'am.
Yeah, it's
Yes.
A, it's B, and let's say someone is asking you to find the CDF at this point, let's say D. So,
Sorry,
to
ma'am.
calculate the, yes,
So from B to D, we are considering it at 0. So total will be 1.
yes. How do you calculate CDF, by the way? For continuous distribution, you find it as an integration f of x dx, right?
Yes, ma'am.
So you will calculate it as a negative infinity to, let's say, D, right? Because we are calculating at D. So when you go like that, how will it work? It will be negative infinity to a f of x dx, right? Plus a to b f of x dx. You will break it like that, no? Right?
Yes, ma'am.
Yes,
Got it,
Plus
ma'am.
b to d f of x dx. So even though these parts are giving you 0, but this part
0,
is
0.
giving 1. So there is nothing like subtraction. Whatever you will get, it's just addition, and that will be 0. So after B, it will be 1 always. Fine.
Yes, ma'am.
Okay. Then we need another 2 concepts also. This is expectation and variance. So if X is following uniform distribution between A and B, then how to calculate its expectation? How do you
Excuse
use
me,
to
ma'am.
calculate expectation of X? Yes, someone is asking some question. Yeah, please.
Yeah, ma'am, in previous concept, I'm not very clear with uniform distribution. Here, why we are using this word uniform distribution?
Yes, sure. I will tell you. Whenever your X, okay, first we'll do that. Whenever it says that X is following uniform distribution means whenever your X will lie between this point A to B, your X will give this value. The straight line means what? At A, it will give the f of x will be this. At B, at this C point also, it will give this point only. Like at whatever point lying between A and B, if you find probability, it will be same. Like it will be constant. Like any event happening between A to B have the same probability. That is nothing but the K, or we say it as a PDF, which is nothing but the 1 upon B minus A. Uniform distribution means in this area. So that means from A to B. If you pick any point and want to know about the probability, it has equal chance. It is uniform because it is uniformly distributed.
It means, ma'am, in between A to B, there we can't draw a graph like quadratic or something like that.
Quadratic means? Yeah, sure. It's a constant graph.
It's a constant graph.
It's a constant.
Yeah,
It is
okay, ma'am.
constant always. Like
It means you find any point in between A to B, then you got the same value
yes,
at any point.
yes,
है ना?
yes.
Okay, ma'am.
For example, there is a game of throwing the dart, right?
Mm-hmm.
There we have a circle, right?
Hmm.
In that circle, like if someone asks you whether you are a player or not, let's say you are not a good player, okay, you are very new to that game. Then if I ask you what is the probability that your throw will be on the center or on the, let's say, blue line is outer line, right?
Yeah.
blue line, yellow line, or red line.
Yeah.
So what is the probability? How, like, is there any probability that your shot will be on blue only, or it's like these kind of circles, right? Concentric circles are there. Sorry, this type of. Yes. So if sorry, this kind of concentric circles are there. So it is uniformly distributed, right? Whenever you throw, you don't know. Your throw will be where,
Yes, ma'am.
because you are very new to it. So it may go to
Yes, ma'am.
anywhere. So this kind of thing, this kind of scenario is known as uniform distribution. Right?
Yeah.
Okay. So does it clear your doubt?
Yes, ma'am.
Okay, then we go for the expectation of uniform distribution. Let's say X is following uniform distribution A to B. Then how to calculate expectation of X? So just by your previous knowledge of discrete random variable, how do you use to find the expectation there?
Long-term mean, which is n multiplied by p.
Yes,
Summation of x into x.
summation of X into probability of that X, right? So
Yes.
here
Yes,
we are doing the same thing instead of one thing. What? It's nothing but the integration. X into f of x dx. So if you calculate it, can you? You know f of x, right? You know x also.
Yes, ma'am. 1
Once
upon
you
b minus.
once you calculate it, you will get a plus b by 2. I'm giving you direct answers because we have discussed these things in detail in the previous
Yes, ma'am.
session. Okay.
Yes, ma'am.
So this is expectation, and we have also calculated variance of x. And variance of x was b minus a
b
dot
minus a whole square by 2
by 12. Okay,
by 12.
fine. So these things we will need in today's lecture for this practice question. So that's why I have discussed this. Now we will go for the
Ma'am, here
yes.
A and B included or not included whenever we are taking an interval?
It will be discussed in the question generally, but it doesn't matter. Sometimes it's included. Sometimes it is not.
So both are denoting the same thing or different thing?
See, it's just they are actually the same thing because it's a continuous distribution. So in continuous, adding 1 point or not doesn't make that much sense. That thing also we have discussed in the previous session. You can go and watch that because it's quite deep discussion. But I can tell you that it's just sometimes it's just a notification. Like you can find in some book this open interval will be denoted as closed interval a comma b also.
Okay.
Okay, because you are taking the, even though it's a closed interval, open interval, you will take the integration a to b, right? So
Yes, ma'am.
in your
So
expectation, it doesn't make that much sense, right?
change.
But you should be aware that these both things are on big scale, they are equal only when it comes to continuous distribution. Okay. Okay, fine.
Okay.
So let me go for assignment, this one, activity question 1. Okay, is my screen visible to you?
Yes, ma'am.
You are able to watch, see the assignment question, right?
Yes.
Okay, and we will try to solve it, considering that you haven't seen the lectures for video week 12.
Okay.
Fine. Okay. So what's the first question? Consider the continuous random variable x, which has a probability density function as shown in the figure. Can you see? Yeah. So we want to find what will be its speed here. So yeah. Are you able to see clearly what the figure is. So you can see that from -1 to 0, your function is taking value 0, right?
Yes, ma'am.
Yes, ma'am.
So, and from 0 to 2, it's taking 0.5 onwards, it's again 0. So how do you write this kind of function? Let me on the writing part also. Yeah. So have you tried this? So the function is taking 0. Is my screen visible?
Yeah, ma'am, screen visible, but the value plotted on graph is not clearly visible.
Yeah. Just a minute. Can you open the same in your laptop if possible? Because I don't think so there will be much questions on graph. But we can go like that. Okay, fine. It's giving 0 to 0 for. So generally when we find the PDF, we just look out for the points for which it is taking non-zero values, right?
Yes, ma'am.
So what are the non-zero values? So if you 0 to 2,
0
it's
to 2.
taking 0.5. So if there is any option which gives you 0.5, just look at that and then we will discuss it, okay?
Ma'am, B1.
Yes, B1. Fine. Yeah. So your f of x, generally whenever we write the PDF, we focus on the point where it's non-zero. So for the range lying between 0 to 2, it's 0.5, and for rest of the part it is 0, right? So that's why the option number 2 is correct. Okay.
Ma'am, your 0.5 and 0 are probabilities, na?
These are PDF, probability distribution. Yes, whenever you pick up any point between 0 and 2, your probability distribution function will be 0.5. Fine.
Yes, ma'am.
It's a probability when you like what's your general in continuous function, we find it like if someone will ask you what is the probability of any part, let's say x is lying between 0 to 2, then what will be the generally we ask for the PDF, so it's a PDF or CDF kind of thing in continuous, so it will be 0.5. Fine.
Yes, ma'am.
Okay. For next question. Okay. Yeah. Is it yeah. Which of the following is correct representation of CDF of x? The same part, if you have a PDF, can you go for the CDF for the same question? So we can calculate it, right? How will you go for the CDF? For CDF, what is the rule? What we do?
Summation, ma'am.
Yeah, summation for discrete random variable, but it's a continuous, so you can't go for the summation. You have to go with the continuous, integration.
Integration up to
Yes, ma'am.
any point in between A to B.
Yeah, so how to go for that? So 0
Yeah.
to 2 is there. So we know that before the 0, your CDF is definitely 0, right?
Yeah, ma'am.
Yes,
And
ma'am.
after the 2, what is your CDF? This 2 thing always we
1.
know. Yeah, it is always 1. So the problem is between 0 to x, 0 to 2. So, but 0 to 2, we can't define any particular point. So we will go for 0 to x, because in between 0 to 2, there are uncountable points, right? So we will
Yes,
go with
ma'am.
the 0 to x integration f of x dx. So what's your f of x? And how will you go with that? So your f of x we know, right?
Effect is, yes, ma'am, 0.5.
So it's 0.5x. Is it fine? And
Yes, ma'am.
I will write it as 0.5x, otherwise 0, right?
Yes, ma'am.
Fine. So there was such kind of option also. Okay. Yeah. So whenever x lies between 0 to 2. Fine. So let's go to next question. What it says. Yeah. Find expectation of x. So expectation of x, how will you go with that?
Yeah. A plus b by 2. It means here a 0 plus 2 by 2. 1.
Yeah. And we have to calculate the variance also. In the next question was about variance. Your expectation of x is nothing but the integration x f of x dx, right?
Right.
0 to 2.
2.
So we know that rest of the part f of x is 0, so we can directly go for integration between 0 to 2 and x. Yeah. So if you go like that also, then 0.5 into this x, integration of x will be x square by 2, and it is 0 to 2. So it's nothing but the 1 only, right? 4 by 2. Yeah. Is it fine? It's 1 only. Then let's calculate variance of x.
1 by 3.
Yeah, it's expectation of x square minus expectation of x the whole square. So we have to calculate this part only. It will be f of x is again 0.5. I am writing it as 1 by 2 and x square dx, right? So it will be x cube by 3.
3.
1 by 2, 1 by 3 and x cube, right? That is 0 to 2. Fine. So it will be 8 by 6, nothing but the 2 by 3. Yeah. Someone told me 1 by 3.
4 by 3.
Is
B
there
minus A. B minus square by 12.
Yes, ma'am, it will be 4 by 3, and then we will put it there in the formula 4 by 3 minus.
Yeah, it is 4 by 3, and then it's okay. She might have taken directly variance of x. Yeah.
Yes,
Yes, ma'am.
Okay, fine. Variance of x will be 4 by 3 minus 1, which is nothing but the 1 by
1.
2. Fine. Okay. Let's go to next question. Yeah. The probability density function of continuous random variable x is given by like that. Find the CDF for the same. So it's taking -1 to 3 for 0.25. Yeah. So your f of x is 0.25 for x lying between -1 to 3. So what's your CDF then? Directly we will calculate for -1 to 3. So that is nothing but the integral -1 to x f of x dx, right? That is nothing but the 0.25 dx. Okay, then this 0.25 I can write it as like 1/4, right?
Yes, ma'am.
And for x,
Yes, ma'am.
x minus 1, it will be integral x -1 to x. So this will be x plus 1/4. Fine. By 4. See, if there is anything like that, then that will be, yeah. And yes, what about beyond 2 that we have discussed earlier, right? After this 0.3, it will be 1 only. But if you put here, let's say 3, then it will be 1 onwards, right? F of x. Generally, we have to write f of x, PDF and CDF for the whole range R. So it will be 0 whenever your x is less than -1. When it's between -1 to 3, it will be x plus 1/4. Whenever your x is lying between -1 to 3, right? And before that, after that, it will be 1 always. Is it clear that why CDF is 1 after the endpoint? Hello?
Yes, ma'am.
Okay. And move to next, expectation and variance. So how will you go for the expectation here? The same thing
1,
we have.
ma'am.
Yes. Okay, you have calculated directly. Expectation, directly the same thing. We'll put in the formula and that's it. Integral -1 to 3 x f of x dx. Like everyone is getting my point. If there is any problem, then please ask me. So it will be x square by 2 integral -1 to 3. So yeah, once you will go with it, 1/8 x square is nothing but 9 minus -1, that is, okay,
1.
yeah.
Ma'am,
So
how 1/4 will come here?
this 1/4 is nothing but 0.4. I am writing this 0.25 as a
0.25.
1/4, yeah. This f of x is 0.25, right?
Yes,
It
ma'am.
is 0.25 only.
Okay.
Okay, yeah.
Ma'am,
Yeah.
we can directly use the formula also, no? A plus B by 2.
Yes, yes. You can directly go for that also. Okay. Similarly, variance. Variance of x. Let's try other formula. What was the formula for variance of x? It was nothing but the b minus c
B
the whole
minus
square by
C.
12. So what is your b? That's 3 plus 1, right?
3 minus 1.
Yeah.
Plus 1.
B minus -1, that means 4, right? 16
Yes,
by
ma'am.
12. So it's nothing but the 4 by
4
3.
by 3.
Yeah, that's your variance. Is it fine? This was all about assignment 1. Is there any doubt for the same? Then please ask me, otherwise we will move to next part.
No doubt.
No doubt, ma'am.
Okay, let's go for 12.2. Yeah, so here is the first question. The length of a statistic lecture has a continuous uniform distribution between 50 minutes to 52 minutes. If one such lecture of statistics is randomly selected, then find the probability of lecture length is more than 51 minutes. Are you getting the question? They are saying that, let's say x is your random variable, which is giving the time for the any statistical lecture, right? Statistics lecture. They are saying that it's following some uniform distribution for how much minute? 50 minutes to 52 minutes, right? So we can have it like this, 50 minutes to 52 minutes. Then they are asking, what is the probability that randomly selected lecture length will be more than 50 minutes, 51 minutes? Can I write the same thing as probability x greater than 51? How will you go for this? How do we calculate this kind of stuffs? So for cumulative distribution function, we know that f of x is nothing but the probability of x less or equal to small x, right?
Yes, ma'am.
So when they ask for probability of x greater than 51, can I write it as a 1 minus probability of x less or equal to 51?
Yeah,
Because
Yes,
the
ma'am.
sum of all the probability will be 1,
is
like
one.
CDF will be 1. So, and we know that x is following the uniform distribution. So we know that the CDF for this one, how we recently we have calculated, right? For uniform distribution function, the CDF, which lies between a and b, it's given by nothing but the x minus a by b minus a, right? Do you remember in the same lecture we have done these things?
Yes.
Okay, let me
Yes,
see.
ma'am.
Yeah, here.
Yes, ma'am.
Okay, so just put the values and that's it. So this is 1 minus what will be your x here? It is 51, right? 51 minus a is 50 and p minus a means 52 minus 50. So it's 1 minus 1 by 2, which is equal to 1 by 2. Fine. Do you understand this question?
Yes, ma'am.
Okay.
Ma'am, I have a doubt from the last activity, 5th question.
Okay.
Can you go?
Last question. 12.1, right?
Yes, ma'am.
Yes. 5th question. Yeah.
Yeah, here, ma'am, y means in every option 1 for x greater than and equals to 2. But we have interval -1 to 3.
Okay. What if you put x is equal to 2? It might be print. It is typo. Yeah, it's typo. See, if you put x is equal to 2 also, because we have calculate
This
CDF
function.
as x
Yes,
plus
ma'am.
1 by 4. If you put 2, then it will be 2 plus 1 by 4, that is 3 by 4, right? It's
Yes, ma'am.
not equal to 1. So yeah, it's a typo only. So okay. Question number 2. The total duration of test cricket match between any two cricket team is uniformly distributed between 90 overs and 450 overs, both inclusive. What is the probability that duration of test cricket match between two cricket teams is more than 400 overs? Like, is the question clear to you this time? The overs is like for any cricket match, the overs are distributed uniformly distributed between 90 to 450 overs. Okay,
Yes, ma'am.
so we can have it like, let's say x is random variable, which is giving you the number of overs for the any particular cricket match, which is following uniform distribution 90 to inclusive, they have said, so I should put this close bracket, right? 450, and asking what is the probability that for any test cricket match the overs are more than 400 overs. So yeah, will you try it?
Yeah, ma'am.
Yeah, sure. Is there anyone who didn't understand the question also? Then please ask me, I will explain.
Yes, ma'am. Explain it again.
Yeah. See, what they have given, the total duration of test cricket match between any two cricket team is uniformly distributed between 90 overs to 450 overs. Okay. Let's say X is any random variable which gives you the duration of the cricket match in terms of over. Okay. And they are saying that X is uniformly distributed between 90 overs to 450 overs. So we can have it as like this. Okay. I can write it like this. Okay.
Okay.
So as it is uniformly distributed, and generally when we solve any statistical problem, we first convert the context in terms of random variable or whatever the applicable part is. So I have made it as, okay, the time is like number of overs taken for any cricket match is X, and it's uniformly distributed between 90 to 450. That was given here, there. And then what is the probability that duration of test cricket match between two cricket team is more than 400 overs? Okay, so we know that 400 lies between 90 and 450, so it's a valid question. So what do we need to find here? Probability that X is number of overs, right? And it's taking more than 400. So I can have it like more than 400. I will write like that only, right? Is the question clear now?
Yes, ma'am.
Yes, ma'am.
Okay, then go for it. How do you calculate this probability of X greater than 400? So
1 minus probability of X less than 400.
less or equal to 400. Whenever the
Yeah.
things comes like this is nothing but the CDF, right?
Yeah, ma'am.
And it's a CDF, and it's a CDF of what? Uniform distribution function for a point 400. And for that, we know we have calculated something, right? So it will be, yes,
400 minus
90.
B
450
minus.
minus. Yeah.
So you
B
have to
minus
just,
A.
5 by 36.
yeah. So just a calculation left here. It's a 5 by 36. So, and option was also there. Okay. Any doubt here? Like, who was asking for the question, do you get the solution also? Or is there any doubt? Then tell me.
Ma'am,
Yes.
ma'am, what difference will it make it if it was like exclusive interval?
As such, there is no. If it was exclusive, if it was exclusive, see, it is like a real life problem. So, like you can't. It was a cricket match, right? So it's not exclusive 90 overs and 450 overs. So it doesn't make the sense in terms of context. So like that. Because even though if they says it's inclusive or not, you will take like that only, right? You will just have notation as open bracket, and rest of the things will be same, because it's given that it was inclusive, so we were able to take this 90 and 450 here, because the numbers in this context matters. If it was not inclusive, you can't use 90, right? You have to use the number next to 90, because if they are saying, okay, 90 overs is not like inclusive, 90 is not inclusive, then you can't use 90 as here. You have to go with 91, and for 450 you have to go with the one less. That means 449, right?
Okay, ma'am. So we have to consider that way, like if it is exclusive, so
Yeah, but generally, like it will be given like this only, because they
ma'am.
have to convey the your continuous random variable, right? Okay.
Yes, ma'am.
Because it might be like 449 overs and some 3 balls. Doesn't make sense, right? Because it may happen that 449 overs and 3 balls. So what will you write that? 449.3 or what? It doesn't make sense in that context. Okay. Yeah, this question is good. The total duration of Test cricket match between any two cricket team is uniformly distributed between 30 hours and 40 hours, both inclusive. What is the 65th percentile for the duration of Test cricket match between any two cricket team in hours? First, understand the question. If you are comfortable, if you are getting the question, then only we will go for the solution. So it's asking, like, one information is given here, that is uniform distribution 30 hours to 40 hours. Okay, that's not a problem. It's asking about 65th percentile for the duration of Test cricket match. How will you go for that? Any idea? It's asking that, like, your x is any random variable which is following some uniform distribution between 30 hours to 40 hours. What is the 65th percentile? Like, what should be the value so that it will be the 65th percentile of the total? What is the 65th percentile for duration of Test cricket match between any two cricket teams? Right? So generally, like, it's asking you about what k should be there so that your this probability will become 0.65. Are you getting the question?
Yes.
Yes, ma'am.
You know what is percentile, right?
Yes, ma'am.
And you also know that the probability of anything can go up till 1 at max. And it is nothing but the CDF. So yeah. So x less or equal to k. The probability of x less or equal to k is 0.65. That is nothing but the CDF of k goes to 0.65. How will you calculate that? Do you have any hint for that in the question?
Ma'am,
will-
we calculate CDF.
Sorry?
Yes, ma'am. By the formula of CDF, we can calculate the
CDF,
value of
ma'am.
K.
Yeah, that's it. That's what's the catch here.
Yes, ma'am.
Yeah, you have to calculate just, we can write this f x less or equal to k as f of k, which is nothing but the 0.65. And for this, we know as x is uniform distribution, you know what is the CDF lying between 30 to 40. So it will be x minus a, that is k minus a upon b minus a is equal to 0.65. So yeah, what's the value? K minus 30 divided by 40 minus
K
30.
minus 30 by 40 by 30.
Yeah.
So 6 by
So this is nothing but the k is equal to 30 plus 6.5, right? 36.5.
Yes, ma'am.
Yes, ma'am.
Okay. Any doubt here?
No.
Okay. Suppose the time taken by a student to finish a quiz is uniformly distributed between 30 and 45 minutes, both inclusive. Find the probability that randomly selected student needs at least 35 minutes to complete the quiz. Okay. Will you try this question?
Yeah, ma'am.
Sure.
Yes, ma'am. Okay.
For at least 35, how will you go for that?
X is greater than 35.
Better than, yes, ma'am, better only.
Yeah. Fine.
Ma'am, it's 2 by 3.
Yes,
Yeah,
ma'am.
ma'am, 2 by 3.
Yeah, it is nothing but probability x less or equal to 35. And yeah, 1 minus 35 by 30, that means 5 by 10,
Yes, ma'am.
right?
5 by
Sorry,
15.
15. So 10 by 15, that is nothing but the 2 by 3, right?
Yes,
Okay.
ma'am.
Yep.
Done. Next is about find the probability that student needs at least 35 minutes to finish the quiz, given that she has already taken more than 30 minutes. Now, how will you go for this question?
If she has already taken 30 minutes, so we can say she have only 15 minutes left.
There are 30 to
Oh.
45 minutes, right? So it was, yeah. So you are saying that it has,
Greater than 35.
sorry. Hello.
No,
Actually, your voice is not audible here. Student needs at least 35 minutes. At least means probability greater than 35
Yes, ma'am.
to finish the quiz, given that she has already taken more than 30 minutes. More than 30 minutes means probability greater than 30, right? How will you connect both of them? So this type of
Greater than
question you have done in the probability, right? When one event, you have to find the probability of one event, given that another event was already happening. Conditional
Yes, ma'am.
probability. But how will you apply here?
Mm, Greater than 35 at least, and greater than 30 is already given. Ma'am, do we have to take the intersection of both?
Yes. At least 35 and more than 30 minutes.
So it will be more than 35.
Yes, obviously. Yeah, that is the only intersection
It
possible,
will be the
right?
same answer.
But given that condition is there,
Ma'am, we use conditional probability.
okay, then go for it.
Yes, ma'am.
It's actually kind of independent event, so the same answer here. Like they are saying that it needs at least 35 minutes. That means it's obvious that it has taken more than 30 minutes, right?
Yes, ma'am.
So the same thing. Even though you calculate, you will get the same thing. Okay.
2 by 3.
Yeah. So let's move to next question. What is that? Is it clear?
Yes, ma'am.
Fine. Okay. The amount of time in minutes that a person must wait for bus is uniformly distributed between 0 and 25 minutes, both inclusive. On an average, how long must a person wait? Yeah. How will you approach this kind of questions? See, they have given that the person must wait for a bus in uniform distributed, like the time is distributed in between 0 to 25 minutes, right? And the question is about on an average, how long the person must wait. How will you go for that?
And we can find expectation of a variable, which is the given interval 0 to 25.
Yeah, that's it.
Which is,
Whenever it goes for the like average time or mean time, then it will be expectation only. And for uniform distribution, the expectation is nothing but the a plus b by 2, that is 25 by 2, 12.5. Right? Okay.
yes, ma'am.
Question number 7. Suppose the random variable x is uniformly distributed between 8 and 24. Find probability lying between 10 to 20. Have you seen this kind of question before? Your x is uniformly distributed between 8 to 24. And calculate the probability for x lying between 10 to, how much it was? 20, right? How will you go for that?
Can we do it like P of x? P of x greater than or equals to 10 plus P of x less than or equals to 20. Is
Greater
it the
than 10
same?
and less than 20.
Yes, ma'am.
See. Here it will be 10, here it will be 20. You are asking for x greater than 10. That means this area. That's what question I was asking, like, and 20 is here. But how will you calculate that? Is there any shortcut for that? Here it
Means
will be somewhat
for x greater than or equals to 10, we will do 1 minus.
Yes, 1 minus probability x less or equal to 10, right? That will give you probability of x greater or equal to 10. That means the whole till 24, right?
Yes, ma'am.
And less than 20 will calculate this 0 part also,
Yes, ma'am.
and you will subtract them. Subtract or add? What will you do? See,
Adding.
whenever you will calculate, whenever you calculate probability x greater than 10, that means it's from 10 to 24, right?
24. Yes, ma'am.
So you have
We'll add
calculated,
extras.
yeah, extras are there. Then how will you remove that one?
Yeah. Then it is a prop.
What if I subtract from, like, if I do something like, I will calculate till 20, x less or equal to 20, fine, that is CDF of 20. And then I subtract the CDF of 10. Will it give me the required part? If I calculate probability of x less or equal to 20, what it will give me? Let's say somewhere here it is 20, right? And this is somewhat, it's following your uniform distribution, and this is some 24, this is 10, and this is 8, right? This is scenario. We want to calculate this part, sorry. We want to calculate this part. Okay?
Yes, ma'am.
So what this will give me, x less or equal to 20? It will give me
8
the
to 20.
area for
4.
8 to 20, right?
Yes, ma'am.
And what this part will give me, x less or equal to 10? It will
8
give
to
me
10.
8 to 10. So if I
Yeah.
subtract this, will it work?
Yes, ma'am. It
So
will
that's
work.
what. And we know how to calculate the CDF for 20 and 10, right? So this is
Yes,
nothing but the F20 minus F10. So yeah, calculate and tell me. Be careful. Here A and B are 8 and 24, okay? Not 10 and 20. So when you go for F20, it's nothing but the x minus A by B minus A, right? That's our CDF.
5 by 8, ma'am.
Yes. Minus, this will be 10 by 16, fine. 5 by 8, yeah, someone has told.
Ma'am,
Yes.
ma'am, why you have not
Yes,
used
ma'am.
1 minus 20 minus 8 upon 24 minus 8?
Sorry, 1 minus
20 minus 8 divided by 24 minus 8.
why 1 minus 20 by 8? Sorry.
Ma'am, because it was
It was, yeah.
less than 20, no? Okay, we are calculating.
See. What is your CDF? What your CDF will be there? It's a uniform function from 8 to 24, right?
Yes, ma'am.
So yes, what is the problem then? Like, you have doubt on this step?
Yes, ma'am. Can you explain it?
Yeah. Like, what's the doubt then? Just clear me first. See, your range is 8 to 24 and you are asking for f of x, right? And if x is following any uniform distribution a to b, then we know that what is CDF for that function?
X
Yes.
minus A.
It will be 0 if x is less or equal to a, right? And it will be x minus a upon b minus a whenever your x lies between A to B, right? And it will be 1 if your x is greater than B, right?
Yes, ma'am.
Okay. Here we are calculating for 20 and 8. Sorry, 20 and 10. Fine.
Yes,
Is it
ma'am.
clear why I have taken F20 and F10?
Yes, ma'am. I got that.
Because this fine. And here my A is 8 and B is 24.
Yes, ma'am.
And whenever x lies between 8 and 24, I can use this formula, x minus A by B minus A. So I have done that only because this 20 is also lying between 8 to 24. 10 is also lying between that only.
Yes, ma'am.
Is there still any confusion?
No, ma'am.
Okay.
Thank you, ma'am.
Yeah, most welcome. Yeah. So can we move to next question? Okay. Question number 8. Suppose a random variable x is best described by a uniform probability distribution with a range 1 to 5. Find the value of a such that probability of x less or equal to a is equal to 0.5. Similar kind of question. Here x is uniformly distributed between 1 to 5 and it's asking for the probability of x less or equal to a, which is equal to 0.5. Okay. Less or equal to only. Yeah.
It
Will
is.
you? Yes.
I was saying it is an easy question.
Yeah. We have done just similar question like that. Okay. This is
Yes,
nothing but the f of a,
Yes, ma'am.
which is equal to 0.5. So once you go like that, f of a is nothing but the x minus a, like a minus 1 by 5 minus 1, which is equal to 0.5. And that will be nothing but the a is equal to 1 plus 0.5. Okay, 2, right? It's 3. Fine. Hello.
Yes, ma'am.
Yeah. Okay. Then let's move to next question.
Yes, ma'am.
Suppose that random variable x is uniformly distributed between 0 and 10. Then find the probability of x plus 10 by x greater or equal to 7. Okay. So x is uniformly distributed between 0 to 10. And to calculate probability of x plus 10 by x greater or equal to 7. So how to go for that?
Firstly, we simplify.
Yeah, just go for the simplification. Okay, it seems there is typo again. It should be x by 10. Now you go. So yeah, how will you go for that? x by 10. So the probability will be nothing but the 10x plus x divided by 10 greater or equal to 7. All right. Let's just solve this part first. Okay. So it will be, 10x plus x divided by 10 greater or equal to 7. This is nothing but the 11x greater or equal to 7t, right? So your x is greater or equal to 70 by 11.
Ma'am, in the question given 10 by x, ma'am.
Yeah, it's a typo actually.
Ma'am,
Or we
but
have to
actually
go then, yes.
we can solve it in that way too, 10
Yes,
by
we,
x.
yeah,
But in that way, and there is an equality we have to solve, then we can find the x lies in between 2 to 5.
2 to 5. Yeah, that is also fine.
Yes,
This is
ma'am.
also fine. So, like 2 to 5 also we can calculate like probability of x less or equal to 5 and like minus we will get the same thing, right?
Yes, ma'am.
Yeah. So okay, we will go by that only.
Yeah, we can check the answer,
Yeah, that's
which
correct.
answer.
X by 10, sorry, 10 by x, right? So yeah, you calculated for that. Same thing, we have calculated this kind of stuff also, right? X less or equal to 2. So I can write directly. Fine. Okay.
Yes, ma'am.
So it will be 5 by 10 minus 0, 10 minus 2 by 10. So it's a 3 by 10. Fine. But there is one catch. This is done, no doubt. But just take one thing. This is greater or equal to 7. And whatever we have done is the CDF. So we have to do 1 minus. Right?
Yes, ma'am.
So then only you will get the
Right answer.
right
It will
answer,
be
right
7 by
probability.
10.
So it will be 1 minus 3 by 10. Fine. So it will be 7 by 10.7. Fine.
Yes, ma'am.
Okay. Is this question clear? Here nothing was the thing was we have to solve this inequality. That's it. Yeah.
Ma'am, how you obtain 10 that 2 less than x1?
Just by solving the inequalities.
Okay.
Okay. Oh, this was about uniform distribution question. 12.2 it was, right?
Can you take one question from
Sorry?
practice 2? Week 11 practice assignment.
Week 11. For week 11, we have a TA session.
But just one question I have.
Okay. Which one? 11 point?
It's in the practice assignment.
Practice assignment. Yeah. Okay, but fine. Practice assignment. Yeah, which question?
Last question.
6 men and 5 men. This one, right?
No, ma'am. No, this just above eighth question. I think.
Okay. Shopkeeper
Yes,
sells.
this one.
It's not very right. Fine. Shopkeeper sells mobile phone. The demand for mobile phone follows a Poisson distribution with mean 4.6 per week. The shopkeeper has 5 mobile phones in his shop at the beginning of week. Find the probability that this will not be enough to satisfy the demand for mobile phone in that week. Yeah. So what's the question here? Yeah. What is the doubt here?
Ma'am, how could we find probability for not enough to satisfy? Like, uh, is it mean that P of X greater than or equals to 5?
The shopkeeper has 5 in his shop. Yeah, greater than 5. Yeah. Yes. In that week, shopkeeper has 5 mobile phones in the shop at the beginning. Yes. Then have you tried like that?
But X greater than or equals to 5. Okay. Then we can do it 1 minus P of X less than or equals to 5. Means I didn't able to solve it. That's fine.
Okay. What is lambda here?
Lambda is 4.6.
4.6, right?
Yes, ma'am.
And X is 5, right?
Yes, ma'am.
And this will not be enough. Yeah, then what's the problem? I think it might be a calculation mistake only.
We can
Just,
means just put in the formula or
yeah.
okay, ma'am. I will try.
Yeah, sure. Okay. So I think we should stop here. If you have any doubt till now, like we have solved 2 activity questions. Do you have any doubt on till now?
Ma'am,
Yes.
ma'am, I have doubt in week 11, one concept, ma'am.
For week 11, we are going to have a TA session. You can have discussion there as it was week 12 discussion. So I was like focusing on that. I think you were in the last session, right?
Yes, ma'am, but I have some work, so I left. I only attended the half of the session.
Okay. There we had left with the one integration. Have you tried that?
Okay, ma'am, that session, ma'am.
Yeah.
No, ma'am, I haven't tried it.
Okay. And he only was ask me the integration, right?
Yes, ma'am. Yes, ma'am. Ma'am, I will try it. If I was not able to solve it, then I will ask to TA
Yeah,
session.
sure. For week 11, we are having the you can ask there, or there are lectures also, you can watch that. Still, if there is any question or doubt, you can put in the discourse and ask there. Till like today's session, do you find any problem, like as you guys haven't watched these lectures? So if there is any doubt regarding week 12, then please ask me, or it's going to add. That's why I'm asking, like
Ma'am,
anything that
in
is
week
not
12,
clear
there
to
is
you.
not any other concept now.
Sorry.
In week 12, there is not any other concept means besides this that you
There
have.
is. We have discussed all this concept in last session, like on 10th December it was. There is one
Okay.
non-uniform. Today we have discussed uniform distribution, right? and the question based on uniform distributions. On that day, we have discussed uniform distribution, non-uniform distributions, and exponential distribution. This kind of stuff is there. You can watch that week, like 10th December lecture, and please come with the doubt if there is any. Today, if there is any doubt, then please let me know that I can solve now about week 12. Rest of the concepts we have discussed in last lecture that was held on 10th December. Yeah. Is this like assignments are clear to you guys, like practice questions?
Yes, ma'am.
Okay, great. Fine then. Let me know if there is anything else. Or we can stop now.
Excuse me, ma'am.
Yes.
Ma'am, end term syllabus.
Isn't it there in discourse? Like it's like
No, it's confusion about ma'am whole syllabus week 1 to week 12.
like I will tell them to put in the discourse so you can have a reference there, right?
Okay, ma'am.
Ma'am, please post
Thank
it
you,
in
ma'am.
the discussion forum, ma'am, please.
Where? Discussion.
Discussion.
Yeah. Sure.
And also the weightage for the weeks, ma'am.
Yes, sure. Isn't it
And-
there? Like I have informed. Okay, fine.
Thank
It
you
will
so
be
much,
there.
ma'am.
Yeah. Okay then. Thank you.